Welcome back, everybody. We're continuing on past example D here, where we had some fractions, and we go to example E, and oh my gosh, the fractions look absolutely horrible, and it looks like if we had to do all that work on part D with just one digit over one digit, what are we going to ever think of doing with three digits over three digits? But if you look closely at that, these fractions are really red herrings. The key here is we're supposed to have a slope of m. That means m equals 0. Therefore, we're dealing with a horizontal line. So we don't have to work to compute the slope. The slope was right there. So we want the equation of a horizontal line that's through that point. Well, uh, all we really need to know is how high it is. It's negative 296 divided by 547. That's approximately negative 0.5 and change. So this point is approximately negative 0.5411, and the x-coordinate, just for fun, 729. That's a fancy way of saying 1/3. That fraction actually reduced to 1/3. So you go over about 1/3 and down about a half, so you're about there. Now, rather than writing that fraction, that point with its two fractional coordinates twice, I'm going to use a standard mathematical trick. We're going to label that point P, and then we can simply call it P everywhere else. We want the equation of the horizontal line through P. Well, the equation of a horizontal line is going to look like y equals b. B is the y-intercept. And in fact, it's the y-coordinate on any point on that line. So it's going to be negative 296 over 547. This is actually mx plus b form, but since m was 0, mx equals 0 times x, so it disappears. So even though this problem looked incredibly scary, it was actually easier than almost any other problem so far in this section. Always call the problem's bluff. Okay, now we bump into one of a pair of important keywords. When you say the two lines are parallel, you're saying that the slope of the first line is equal to the slope of the second line. So really, when you say parallel to this line, that's essentially language that tells you to get M2 using this line. Now, of course, on a test or homework, they'll never write this line in slope-intercept form where you could read it directly off. They're going to put it in something like standard form here, where you have to do a little bit of work to get the slope out of it. But there's not a whole lot of work to do there. So you start with what they give you, and then start turning it into slope-intercept form. I'm subtracting a 2x from both sides. And then I'll divide both sides by the negative 3. A negative 2 divided by negative 3 is 2/3. And then minus a positive divided by negative is a negative 5/3. I don't need that y-intercept. What I need is that slope. The slope of the given line, m1, is 2/3. Therefore, the slope of the line that we're after, the second slope, is also 2/3. That's what I'm after to get the equation of the line. Well, now we have a slope and a point. So we're going to do point slope. I'm going to go ahead and graph this thing. Let's see. we have the point 1 comma negative 4. 1, negative 4. So there's the point. And we're going to have a slope of 2/3. That means that if we go over 3, we'll go up 2. So I'm drawing a slope triangle here. Over 3, up 2. So that graphs our line for us. So this is the second line. And we simply need to have its equation. Looks like the y-intercept is going to be approximately 4 2/3. So we can use this graph to check ourselves when we get done. Well, y minus y1 equals m x minus x1. We're using the second slope, and we'll use this point on the line. Y minus a negative 4 is going to be 2/3 x minus 1. So we have y plus 4 is equal to 2/3 times x minus 2/3. Subtract a 4 from both sides. Now when I subtract here, I can just subtract 4. I'll get y 2/3 x minus 2/3. Now I've got to subtract 4 here, but I want to write 4 in terms of thirds. So 4 would be 12/3. So instead of writing 4 here, I say minus 12/3. And then I don't have quite enough room to squish it there, so I'm going to jump over here and do y equals 2/3 x minus 14/3. Well, if you check 14/3, 14 divided by 3, that's 4 2/3, which is what we expected down here. So, one of the reasons I like to graph things as soon as possible is because I can use a graph to check myself. Now, this is the second line. I think if I go ahead and graph the first line, although they didn't tell me I had to, you can see that they're indeed parallel. The first line had a y-intercept of negative 5/3. Well, negative 5/3 is going to be negative 1 2/3. 5/3, negative 1 2/3. So it'll be about there. And then we'll do the exact same slope triangle. We'll come over 3. And then we'll go up. That's not exactly over 3. That's a little bit slanty over 3. Then we'll go up 1, 2. So there will be, modulo my ability to draw well, there's the first line. So this is line 1, which is what we were given first. And notice that the two lines are indeed parallel. Now, parallel was one of 2 keywords that work almost the same. If I'm doing my job right, the next page will say perpendicular. And in fact, all that changes is the word parallel to perpendicular. So we don't have to do a lot of the work that we did in this previous. We can reuse some work here. So we have this line here. This is line 1. And we know that M1 from the last problem was 2/3. Now, the important thing to remember here, perpendicular lines, these are lines which meet at right angles. Perpendicular lines have reciprocal opposite slopes. So that means that M2 is going to be negative 1 over M1. So for us here, the slope of our second line is going to be negative 1 over 2/3. But remember, whenever you do the reciprocal of a fraction, you simply flip the fraction over. So there's m2. Then we can do, just like the last problem, we can do the point slope form. Here we're going to be using m2, x minus x1. We have one point to use. We've got to go through that point, negative 1 comma 4 again. Remember that our original line L1 is about there and about there. So that's L1. And we're going to be making a line through through this point perpendicular to that line. It would intersect at right angles. Well, that means that our line is going to look something like that. It's got to make a right angle. So in particular, that means that if this slope was positive, then this one has to be negative. That's why you got the negative there. You changed the sign on the slope because one of these guys is positive and one is negative. And you're going to change the run is going to become a rise. And the rise here is going to become the run here. So that's why you flip the fraction. So substitute the numbers in and see what we get. Y minus y1, well, y minus a negative 4, negative 3 halves x minus a positive 1 equals, well, distributing through the parenthesis on the right, negative 3 halves times x, then negative 3 halves times a negative 1. Watch when you distribute, watch the signs. It's easy to forget one. Now, if I'm thinking ahead here, I realize that once again I'm going to be adding this 4 to a fraction or subtracting it from the fraction on the other side, and I'm going to need the common denominator. So why don't I just break down and get the common denominator now? These are halves, so I'll change 4 to halves. 4 is 8 halves. Now, I'll subtract 8 halves from both sides. I have 3 halves minus 8 halves, so I have 3 apples minus 8 apples. That's a minus 5 apples. Well, if I start here and I do a negative 3 halves slope, that means if I came over, then I came down 3. So I have this slope triangle. So negative 3, 2. And if I connect those 2 points now, notice that right there is negative 5 halves, negative 2.5. And those 2 lines are perpendicular, which is what we wanted. Let's cut it here just to make sure that we don't have huge video chunks up on YouTube, and we'll finish the next 2 examples in a second.